Many of us dream of finding that one hustle or job that can financially set us up for life, right? Something that will help me finally live in that secluded, eclectic, floor to ceiling glass window home overlooking the water and mountains in the Pacific Northwest. Or at least a job where I can set aside a portion in my savings each month and a system that will help it grow over time. Hey, not every dream has to be wild and exciting. This saving strategy I'm dreaming about is what we call an annuity, and it's one of the ways to save money for retirement. And if annuity is a new to you, should I pause for laughs? No? You're not alone. According to one survey, more than half of Americans don't really understand what they are. But no matter where you're from, together we can understand the power of an annuity savings account and how they function so we can make the most money and potentially live that retirement of our dreams one day. I'm Jason Guglielmo, and this is Study Hall Real World College Math. Over the past few episodes, we've been focusing on important math involved in the world of finance. For instance, we talked about simple and compound interest, and how understanding the costs that come with borrowing and lending money can help us make important life decisions. If we're lucky, we can even use that knowledge to invest and have our money make us more money without us really having to do anything else. And if we can make money without doing anything, it makes sense that we can accumulate even more when we are doing something. In the last few episodes, we focused on the interest attached to lump sums of money if we just let them sit there. But now we're going to talk about what happens if we keep adding money to that pot. One way to make the money you already have work for you is with an annuity, which I mentioned before. The lingo can be kind of confusing, but technically an annuity is what we call a series of payments that are made at regular intervals. These can be things like regular deposits to a savings account, or insurance, or mortgage payments. With some types of annuities, you can deposit a lump sum and take money out at regular intervals. Or we're going to focus on the type that we pay into regularly and how that can save you money. And these types of annuities are important to know about early on because, like we've explored so far in our finance unit, money, interest, and time are deeply linked. To get into annuities and how regular deposits can change our interest calculations, meet Zolkar, a first-generation college student at Study Hall University. Go SHU! He's ready to crush the second semester of his sophomore year because Zolkar just found out he's been awarded the Cinquefoil Scholarship, which means his entire tuition is paid for. His room and board is covered, and starting this semester, he gets a no-strings-attached $2,000 stipend every January and July until he graduates in 3 years. The stipend also has an option for sophomore recipients. Instead of receiving the full $2,000 each semester, the university can invest $100 of each stipend into an annuity savings account with the Study Hall University Credit Union. Go SHU! Now, Zolkar is hesitant on whether this account is worthwhile. I mean, $100? With $100, Zolkar could go out with friends, buy some clothes for a party, and put gas in his tank now instead of later. So, Zolkar has some options here, and the only way to assess his options is to understand how an annuity account works. Because even if it does accrue a little extra money here and there, we need to know how much and how often. Like, if he only earned $1 every year for 3 years, then maybe that's not worth the inconvenience of not having the full stipend up front. According to the Study Hall University Credit Union Go SHU website, the annuity savings account that's part of the Cinquefoil Scholarship is an ordinary annuity account, and it pays 8% interest compounded semi-annually. Yikes, that's a lot of finance words. But like we've seen throughout this course, specific terms are there to help us talk about precise ideas and build new ones. So, based on what we learned in our episode on compound interest, that sounds like if Zolkar leaves the $100 sitting there without having to do anything, he'll earn at least $8 in interest. That's based on our compound interest formula, and assuming he'll earn 4% interest the first half of the year and 4% interest the second half of the year, which is what compounded semi-annually means. That annuity word might mean there's more going on here, but $8 for free as a college student? Why not? So instead of getting his full $2,000 stipend, Zolkar gets $1,900 while $100 are put into his ordinary annuity savings account every January and July. For the next year, Zolkar is busy cramming for exams, attending parties, and doing all the latest TikTok dances. He forgets about his savings account, and it isn't until the week before New Year's he thinks to check his annuity account again. And when he looks, He was robbed! His account only shows $100 was deposited in January, another $100 was deposited in July, and just $4 in interest. Feeling shortchanged, Zulkar sends an email to the bank asserting that they owe him $4. The Study Hall University Credit Union, go SHU, was prepared for such a reply. They also know most people do not know how an annuity works, so they're always prepared to break it down. Here's the math they walked him through. First, let's define an ordinary annuity account, which is a specific type of annuity that's a series of equal payments made at the end of whatever time period we're dealing with. For Zulkar, that means his interest payments happen at the end of each compounding period, so at the end of every 6 months. So in January 2023, Zulkar's $100 was just $100. Then in July 2023, Zulkar earned 4% interest, but just on that first $100. His next $100 deposit also happened in July, but he doesn't earn any interest on it until it's spent an entire 6 months compounding in his account. The key is his $100 deposits accumulate interest independent of each other. That January 2023 $100 deposit earns interest on one compound interest schedule, and that July 2023 $100 deposit is on another. So we have to use our compound interest formula twice, which you can learn more about in our last 2 episodes. By the end of 2023, his account looks like $100 times 1 plus 8% divided by 2 for the January 2023 deposit, plus the July 2023 $100 deposit, which won't earn any interest until January 2024. So his available balance is indeed $204. In fact, knowing we have to use the compound interest formula separately for each $100 deposit, we can calculate how much money Zulkar's account will have in the future after a few more regular equal payments in addition to the interest they earn. First, let's think just a little into the future and calculate how much will be in his ordinary annuity account in January 2024. To do this, let's focus on just the original $100 deposit from January 2023 for now and ignore the other upcoming deposits. In January 2023, that first $100 deposit is only $100. Then, when the next payment period begins in July 2023, the bank applies the semi-annual interest rate to that $100. And then when the third payment period starts in January 2024, the same semi-annual interest rate gets applied again. So we can put all that into our compound interest formula from last episode and get $108.16. Remember that individual deposits in an annuity accrue interest separately, so we'll set that aside for a second. Now, let's only consider the $100 deposit that was deposited in July 2023. In January 2024, that deposit will get its first dose of interest. So we can plug it into our compound interest equation, which comes out to $104. Note that t here is 0.5 since only half a year has passed. Okay, let's also set that aside for now. Then finally, a new $100 deposit will hit his account in January 2024. Since no time has passed since it was deposited, it won't accrue any interest yet. Now there are 3 different $100 deposits compounding interest separately, and the total value of Zulkar's ordinary annuity account is all 3 added together, which comes to $312.16. And this trend will continue for the rest of Zulkar's stay at university. Every 6 months, each $100 previously deposited earns another bit of interest, and the most recent $100 deposit is only at the start of its journey. So, as long as Zulkar's scholarship continues to invest $100 every 6 months for the next 3 years, when he graduates, Zulkar will have 6 deposits plus all the compounded interest each one earned. We could repeat the strategy we just used and calculate the interest each deposit earns separately and add it all together to get his final savings. But calculating the interest for each annuity payment is a lot of math. Instead, we can do some algebra to make it a bit more compact. His last scholarship payment will be made in July 2025. So let's figure out how much will be in his ordinary annuity account at that point. We'll just write A for annuity to save some space. First, let's write out what we'd end up with if we did look at each payment separately. That first payment would have interest applied 5 times, and the second one 4 times, and the third one 3 times, all the way down to that last payment in July 2025 that hasn't accrued any interest yet. Now, when we're trying to simplify stuff with algebra, we can start by looking for stuff that each term has in common. Notice how every term on the right-hand side of the equal sign has that 1 plus 8% divided by 2 factor except for the last one. Well, we can fix that by multiplying everything on both sides of the equation by that 1 plus 8% divided by 2 one more time. And that might be helpful later if we want to write the multiplication more efficiently. Now notice that both of these equations share a lot of terms. Sometimes it helps if we shift terms from side to side, so we're going to subtract our original equation from both sides of our new one, because we should know if we subtract something by itself, it cancels out. That might seem weird, but each side is equivalent, so subtracting the same value from both sides will keep the equation balanced. That'll help us simplify our equation by subtracting all the middle terms on the right side of the equation, leaving us just the very first term minus the very last term. Remember, our goal is to make this equation compact and figure out the total value of the annuity. So on the left-hand side, let's combine the a's, and on the right-hand side, both terms have 100 as a factor, so we can pull that out. Well, then we just want the value of the annuity by itself, so divide by the 0.08 divided by 2 on both sides of the equal sign to get a alone, and voila! And if we look back at what each of these pieces stood for, we can create a general formula that will work for any ordinary annuity calculation. In this equation, the 100 represents the routine $100 deposit Zolkar's scholarship is depositing every 6 months. Let's call that regular payment M. The 0.08 is just our interest rate in decimal form, so we will call that R like we did in our other interest formulas. And the division by 2 works the same as our previous interest equations too. It's representing the compounding period, because here the interest is compounded semi-annually or twice a year. So we can use the letter N to represent the number of compounding periods per year, like before. Then there's the 6, which happens to be how many total payments are deposited into Zolkar's account. That turns out to be N times T, where T stands for the number of years. And now by using variables, which stand for ideas, we end up with a much simpler equation we could use for an ordinary annuity. Doing the math, by the time Zolkar graduates, his ordinary annuity account will have about $663.30. His scholarship deposited $100 6 times, so in the end he would earn $63.30 from compounded interest, which isn't as much as he'd hoped. So with our general annuity equation, we can work backwards to figure out how much Zolkar could have earned if he'd increased his monthly payments back in January 2023. Like, say he wants his annuity to be worth at least $1,000 by 2025. That means A is equal to 1,000. And it's the same bank account, so there's still the 8% interest rate compounded semi-annually. So R is equal to 0.08, and N is equal to 2. And his scholarship is promised to invest until he graduates in 3 years, so T is 3. Plugging those values in, we can solve for M to see how much money he should have deposited each payment period to reach his $1,000 account goal. Thought Cafe will help us with the simplifying and solving for M, which ends up revealing he would only need to regularly deposit $150.76 in order to end up with his $1,000 goal. Fortunately, Zolkar has the ability to adjust his annuity payments to accommodate his needs. If there's a specific amount of money he wants to earn, he can adjust his monthly payment to achieve it. Or he can decide whether his potential earnings are even worth it. It may be nice to earn some interest for the future, but maybe the money is worth more to him right now. Overall, understanding how different types of investing work help us achieve our goals, like that secluded, eclectic, floor-to-ceiling glass window home overlooking the water and mountains in the Pacific Northwest. Those kinds of financial dreams don't just happen, but with the tools we've learned, we can set manageable goals and adjust our strategy to achieve them. Although it might take a long time to save up the money for the purchase of our dreams, as we've learned in the previous videos, interest isn't just about loaning money. Often, we'll be the borrowers, and in the next lesson, we'll talk about how those same regular payments could go towards paying off loans. Go SHU! Thanks for watching Study Hall Real World College Math, which is produced by Arizona State University and the Crash Course team at Complexly. If you like this video, give us a like and subscribe. You can learn more about ASU and the videos produced by Crash Course in the links in the description. See you next time.